Good morning to all. Welcome to the Bhaskars classroom. In this video, we are going to discuss about phases of compiler by taking the simple example. As we know that the compiler has 6 phases. First one is lexical analysis. The second one is syntax analysis. Third one is semantic analysis. Fourth one is intermediate code generation. Fifth one is code optimization. Sixth one is code generation. You know that each and every phase output. Okay, so once again we discuss about what can be generated as output in each and every phase. The lexical analysis phase take the source program as the input and generate the tokens. And syntax analysis take the input is tokens and generate the parser or either parse tree. And third phase of the compiler is a semantic analysis, which can take as the input is parse tree and generate the semantic tree. Semantic tree. And fourth phase of the compiler is intermediate code generation, which can take the input is semantic tree and generate the output is tree address code. Tree address code. And fifth phase of the compiler is code optimization, which can take the input is tree address code and generate the optimized tree address code. And last phase of the compiler is code generation, which can take the input is optimized code as the input and produce the output is target program, that is assembly language. Now to understand clearly, we will take the simple example as a source program and we will see that each and every phase can generate the outputs. Now this is the given taken source program, that is called as x equals to a plus b into 10. Okay, so that is the source program. You have to given as input to the lexical analysis. As we know that the lexical analysis take the source program as input and it perform the 3 important tasks. One is read the source program character by character and break up into some groups. Those are called as lexics, and then it can be converted into a tokens. So now we have to know that what is a lexeme. Lexeme is a sequence of characters. And what is a token? Token is a sequence of character having some collective meaning. Where how to recognize the tokens? The simple example for the tokens is that is any key words, any identifiers, any operators, any special symbols, any numbers. Those are called as a tokens. That means before generating the tokens, now the lexical analyzer can generate the lexemes from the source program by reading the input symbol or source program by character from left to right. Now this is a given source program. Now come to here, we will understand clearly what is the output of the lexical analyzer. Now the source program is x equals to a plus b into 10. Now the lexical analyzer can read the source program x. Now it can encounter that new symbol assignment operator. Now while reading the source program, it can divide it into a one lexeme. Now that lexeme, x is a lexeme. If x is a lexeme, that can be converted into token. Now x is an identifier. Now it can represent that identifier 1. And next one is equals to, what is the next one? A. A is a, that is called as a character and it can be converted into lexeme. After that, it can be generated into a tokens, that is called as identifier 2. And then plus is an operator. And next one is identifier 3, that is called as a T. And then 10. So this is the output of lexical analysis. The second phase of the compiler is the syntax analysis, which can take the input is a tokens and it can generate the output is parse tree, that is called as grammatical structure of the tokens. Now, while constructing the grammatical structure in the syntax analysis, we have to remember all the root words must be a operators and the child node must be a operands. Now come here. Identifier 1 equals to identifier 2 plus identifier 3 star 10. While evaluating this expression, initially we have to perform the multiplication operation. So that's why we will construct the grammatical structure or parts tree like this. So initially we will do the multiplication. This result can be added to the identifier 2 and this result is equals to identifier 1. That is the output of syntax analysis is parts tree. And the third phase of the compiler is syntax analysis, where we will construct the output is semantic tree. Okay, by taking the inputs, input is parts tree. Now, is there any numeric values? Those can be converted into either real or either float values. Now, identifier 1 equals to identifier 2 plus identifier 3 into 2 float of 10. That is the semantic tree. And fourth phase of the compiler is intermediate code generation, in which the intermediate code generation can take the input is the semantic tree and generate the output is 3 address code. Now, what is a 3 address code? We have to apply the two important rules: minimum rule as well as maximum rule. What is a minimum rule? Which can accept only minimum is 2 operands with a single operator. What is a maximum rule? Which can accept only 3 operands maximum with 2 operators. Let us see here. Where we have to use the temporary variables for storing the values. Where the T1 can be used to store the into float of 10 and T2 equals to ID3 into T1 and T3 equals to ID2 plus T2 and ID1 equals to T3. Initially, by taking the temporary variable T1 can be used to store the into float of 10 value and this is the T1 which can be multiplied with the identifier 3 which can be stored in the T2 and T3 is ID2 plus the T2 and ID1 equals to T3. That is the 3 address code generated in the intermediate code generation. And fifth phase of the compiler is code optimization. As we know that the code optimization phase take the input is that is called as 3 address code and it can generate optimized 3 address code. That means we will minimize the number of lines from the 3 address code. If it is a possibility, then we have to reduce the number of lines from the 3 address code. Now here T1 equals to ID3 into 2 float of 10. That means this entire value can be stored in the T1. That is the T1 equals to ID3 into 2 float of 10. And next one is ID1 equals to ID2 plus T1. That means let us check out what is the conditions of 3 address code. That is a minimum rule as well as maximum rule. Minimum rule means minimum it can accept 2 operands with a single operator. Maximum is 3 operands with 2 operators. ID1 equals to T3. That is a 2 operands with a single operator. Maximum is 3 operands. That is called as a T2, ID3, T1 with 2 operators. So here also in the code optimization phase, which can accept maximum is 3 operands with 2 operators as well as 2 operands with single operator. That is a 3 address code. So now T1 equals to ID3 into 2 float of 16 and ID1 equals to ID2 plus T1. Now finally the compiler, I mean the code generation phase. The code generation phase can take the input is optimized code and generate the assembly language. In the assembly language code, that is called as in the code generation phase, while generating the assembly language, where we have to use that some instructions and registers to generate the assembly language. Move is an instruction. Okay, on R1, R2, R3 and so on. Those are the registers. By using these registers, we can store the values. Now come to here from the optimized code. Okay, into 2 float of 10. Okay, move is an instruction which can be used to store move the values into float of 10 into the R1. That means in the R1 which can store the into float of 10 value. And next one is there is a multiplication, that means where we have to use the mul as a instruction to multiply the value with the ID3. That means mul ID3 with R1. And next one is there is an addition operator, that's why we have to use add ID2 comma R1. That is the R1 can store the result value. And finally move ID1 into R1. This is that is called as output of compiler. That is the input as a source program gets equals to a plus b into 10, and from this source program we have to generate each and every phase in the compiler, and then finally we generate the assembly language. Thank you.